right, so we are ready to start chapter 5, which is about decimals. And you're going to notice in this module, we are not completing chapter 5. We're just doing sections 5.1 through 5.4. And we're going to kind of fill in chapter 5 a little bit here and there in some other modules as those topics come up. All right, so looking at today's topics, we have, let's share this. We have section 5.1, naming decimals and converting decimals to fractions. So before we start this section, it's very handy to know all of the place values for all of the decimals. And it's kind of tedious to write out the whole chart and have you write out the whole chart. So what I've done is I've made a screenshot of the textbook. Now, this might be a smidge blurry, but you can just go to the openstax.org webpage, which you can just see I included that at the top of the page. And this is section 5.1. And I scrolled down quickly. It was maybe I don't even know how to judge it. Oh, here's my scroll bar on the side. You can see on the side, it's actually not very far down the page, and you get to this chart here. And I wanted both charts that you can see, I wanted both of them available to you. So you can either pause this as you're doing your homework or copy this down, or you could go directly to the web page and even print out this page if it's something that you need. You can even see right by that scroll bar, there's a print button available as well here. I don't think you can see my mouse, but here's the scroll bar I was talking about. See how it's not very far down? And then here's the print button. So when you're on that web page, you can just use those two options. Oh, and here's the web page I was talking about. You guys know where web pages are. Okay, so 5.1. And so first I want to talk about how decimals and fractions are related, because a lot of times people can read fractions no problem, but they can't read decimals. And I wanted to show you how they're the same thing, especially when we get into converting between fractions and decimals. It's going to be a lot easier to convert if you know how to read the number. And so first we have 1/10, and you'll notice in the fraction, you already know what it is, 1/10. And the decimal, it's the first place value after the decimal point. So that's 1/10. And then moving 2 places, so that'd be like a dime, 10 cents. Moving 2 places over, we have the hundredths place. That's 1/100th, just like the fraction 1/100 or 1/100th. So if you can read the decimal, then you can write the fraction, because if you read the decimal with the correct words, then the fraction that is associated with it, it's telling you what the denominator is right there. 1/10, the denominator is 10. 1/100th, the denominator is 100. 1,000th, the denominator is 1,000. So here's all those TH words I was talking about earlier. All of these decimal words end in a TH. All right, so then looking at the bottom at the place value chart, we have the decimal in the middle. And let's see if I can write on this in the same direction. This decimal is the and when you're reading a number. That's where the and goes. And so if I had, I'm just going to fill in a number real quick. 1313 is the address of the Munsters. Okay, if I was reading this number, people all the time say 13.13, but that's not the proper way to read it. That's not the name of it. And so definitely that first part is 13. And then we say and then you read where this number ends. So this number ends in that place right there. So to read this, I would say 13 and 13/100ths, because after the decimal, I do have the number 13 and it ends in the hundredths place. All right, so we are going to start writing these out on the notes. Again, I guess if you wanted to take a screenshot of this chart, you could just rewind the video, but you could just go to the website. This is section 5.1. click over here on the left and it will take you right to this page. Okay, so let's look at the actual notes. And the first number we have right here. So I know everything before the decimal. That's going to be just reading that number 3. Then there's the decimal, which is the word and. And then I want to take this whole number, 518. So I'm going to write that out, 518. And the last word is going to be, where does that end? Where does that 518 end? So we have the tenths place, the hundredths place, and the thousandths place. So the last word was thousands, so I'm going to write that right after the 18. Three and 518 thousandths. So the number before the decimal, you write like normal. The number after the decimal, you write like normal. The only extra thing you're gonna have to worry about is where does that number after the decimal end, and that's gonna be the last word, in this case, thousandths. For part B, on the left side of the decimal, we have negative 145. And there's the decimal, so I write the word and. And then on the other side of the decimal, I just have a 3. So, and 3/10. If you're not sure how to find the tenths place or how I found the thousandths place above, go ahead and spend some time looking at that chart that I just showed you from the textbook. And that is how I'm getting it. But the things you want to focus on are the things I told you to not focus on last time, but they're necessary now. We need that and we need that TH at the end. Both of them have the and where the decimal is, and it has the TH at the end of the last word. Okay, so moving on to the other direction, now we're going to write the decimals. So they're giving us the words, and we write the decimal. So I notice right away, I have the word and, so that's going to be where my decimal point is. And then I have the TH word there at the end. Okay, so before the word and, I have 314. And is going to give me the decimal. And then I have 35 thousandths. Now, don't do this. Don't write 35 and call it a day, because that's not the answer. What we need to do first is we need to figure out how my eraser works first. Let's see. Get rid of that. That is not the answer. Come on, this is taking too long. Okay. What we need to figure out is where the thousandths place is. So I'm just going to kind of draw a line underneath to get the tenths, the hundredths, and the thousandths. So my number needs to end right there, which is 3 spaces away from the decimal. However, 35 is only a 2-digit number. So 35 has to end in that third spot. And what I'm going to do is I'm going to fill in a 0 in any extra empty spots that are left over. So what's more important, no, not more important, but what you have to remember is that that number has to end at that last word that they give you. And then any extra spaces, just fill in with a 0. Now for part B, I do not have the word and, but I do have this TH word. So I do know that a decimal is involved. So if they only give you those last few words and there's no and, that means there's nothing before the decimal. So I can just write a 0. I don't need to say nothing and 98 thousandths. That's unnecessary. I can just say 98 thousandths. So again, we have a 2-digit number. We have that 98. It's only 2 digits, but we have the thousandths place. So 1, 2, 3 spaces.
for thousandths, tenths, hundredths, thousandths. And I'm going to make sure that 98 lines up in that last spot. And since I have an empty spot in front of the 9, I put a 0 there. Okay, next topic is to convert decimals to fractions or mixed numbers. So if a decimal is like the last decimal we did, where there was a 0 in front, then that's going to be a fraction, just one number on top, one number on bottom. However, if there's the and, if there's the number in front of the decimal, then that is going to be a mixed number. So I'm going to start writing this out exactly how I would read it, and then we will worry about reducing. So if I was to say this number in words, I would say -3 and 125 thousandths. So I'm going to write that fraction that matches up with the words I just said. -3 and, so there's my fraction, 125 thousandths. The way you read the decimal is the way you write the fraction. Now, I don't need to worry about the front of the whole -3 part. That's fine. So what I'm going to do is I'm going to reduce 125 into 1,000, and 125 goes into 1,000 8 times. So I'm going to reduce. And remember, if you don't see the number I write first, write down the number you do see. Maybe you just know that a 5 goes into it. Or maybe you're thinking about quarters and you know 25 goes into it. And then you can reduce again to get the fraction 1/8. So I know that this one in the box is the answer that I'm looking for, because I wrote the word simplify in the instructions. So make sure when you see that word simplify or reduce, you're writing your answer in lowest terms. Okay, part B, there's no whole part that starts with a 0. So this is only going to be a fraction. I have 942 on top. And then we're probably getting pretty good at this 3 decimal places, because this is the 4th problem in a row that we've had 3 numbers after the decimal. So that is 942 thousandths. So I'll put 1,000 underneath. Now 942 and 1,000 are both even. So I'm going to start there by saying 2 goes into 942, 471 times, and 2 goes into 1,000, 500 times. And there's more stuff that goes into 471. I could use my divisibility rules to see that 3 goes into it. However, there's not much that goes into 500. 500 is just made up of a bunch of 5s and 2s. And so since neither 5 nor 2 go into 471, we are at our final answer already. So remember those divisibility rules that we learned before. We can just use them here to quickly reduce numbers. Now, I don't know that 2 goes into 942 that many times off the top of my head. I just know how to efficiently use my calculator, because 942 is even. Therefore, I can divide it by 2 and very easily get that 471 on my calculator. All right, last one. We have 16 and 25 hundredths. Now this one, you might be able to shortcut. You might know what 0.25 is. And if you do, great. Use anything you already know. That's fabulous. But if you don't know, we can just practice again. We have 16 and 25 hundredths. And now we see 25 over 100. Well, I know there's 4 quarters and $1. So it must go into 25. 25 goes into 25 one time, 25 goes into 100 4 times. And so we end up with 16 and 1/4. So we wrote it as, first you read the decimal using the proper words. And I emphasize that because if I told you 0.942, that doesn't really help you write it as a fraction. But if I tell you 942 thousandths, that makes it a lot easier to write it as a fraction. So using the proper vocabulary, say what the decimal is, write it as a fraction, and then reduce. That's how you convert to fractions or mixed numbers. All right, we are done with that. So we're going to pause the video, and that will give you a chance to go do your homework. And we're back. So we're going to do section 5.1b, ordering and rounding decimals. So ordering means draw it on the number line, and it means greater than or less than. It just means what numbers go in what order. So I'm going to draw a number line for number 1, and I'm going to do all 3 parts on it. And none of these numbers are bigger than 1. So I'm going to just make my number line for this problem between -1 and 1. Now this isn't really a choice you have to worry about making because you've done number line problems before on the homework and they give you the number line, you just have to put the dot on there. But if I am drawing it like I am right now, I don't need to make it excessively humongous. I can just make it from -1 to 1. And in between -1 and 1, in fact, specifically halfway in between, I have a half. And on the left side, I have a -half. You don't need to put every decimal in there, but just enough to give you an idea of what goes on the left and what goes on the right and whatnot. So for the first one, for part A, we have 0.25. So that's going to be in between 0 and +1/2. So we have 0.25. I guess I could have drawn an A right there for part A. And then for part B, I have -0.49, -49 hundredths. And so really the catch here, the trick here is what side of the 0.5, the -half, does this number go on? Does it go on the left side over here? Or does it go on the right side over here? And since 49 hundredths is just a little bit greater than -1/2, it's going to go right here just on the other side, just on the positive side of -1/2. So this other one, I can't erase it without erasing the whole number line, so I'm just going to put an X through it. That was just a multiple choice, and that turned out to not be the answer. All right, and finally, -15 hundredths. Well, 15 is even closer to 0, so it's going to be somewhere over here, -15 hundredths. So I just got to get those, and really, I think the decimal part, most of you will be able to get the hang of just because of your familiarity with money. However, it's those negatives that always seem to sneak up on people. All right, so the next part of this, ordering decimals using less than or greater than, what we want to check here is each place value step by step until we find out where they're different. So let me just kind of rewrite A real quick to give you an example of what I'm talking about. So I have 4/10, but I can always add zeros at the end to say if I'm comparing them. So one way to look at this is I wrote them with the same number of decimal places, and I can compare 400 to 408 to say which is bigger. It's just like that. That'll work every time. Another way to do it, especially if you don't want to rewrite it like I did, is you just think of it one step at a time. So 4 and 4, they're both equal. 0 and 0, they're both equal. 0 and 8, well, 8 is bigger, so the one on the right side is bigger. 4 tenths is less than 408 thousandths. But it is not much less. The difference isn't even a penny. They're so close together. So that's why we want to check place by place. Part B, very similar. However, we have those negatives, which makes everything backwards. So if you are having a hard time doing this in your head, then what you can do is just draw a number line. I'm going to just do it by tenths. And so for -3 tenths is definitely right there. -35 hundredths or 3.5. I'll just put a 0 there to help out. I should have done that before. All right, so that -35 hundredths, 35 is going to come right in between 30 and 40. And so we can see the one on the left is always going to be the smaller one. So the -35 hundredths is smaller. So again, we were comparing like 30 compared to 30. The only difference is this time it's negative, so we have to reverse that order. So -30 hundredths is greater than -35 hundredths. And finally, in this section, we are going to round the decimal to the given place value that's listed. And we've rounded before. There is no difference in rounding rules. You just have to be careful that you're in the right place. So we have these THs, which are the decimal words. So here we're going to round to the nearest whole number, 38 and 7 tenths. So I'm looking at the 8 and I ask the 7 what to do. The 7 says round up, so I'm going to round up to 39. The hundredths place, that's where the 4 is located. So I'm looking at the 4, I ask the 9 what to do. Ooh, that circle even covered up the 4, so I almost forgot what number I was talking about. But that 9 is telling us to round up. So we keep everything in front, all those numbers in front the same. The 4, well, the 9 told it to round up to a 5. And unlike whole numbers, we don't have to fill in with zeros. So I had a 3 spaces. Let me clear this up a minute. I had 3 spaces after the decimal in the question. I only have 2 spaces after the decimal in the answer because this extra 0 here is unnecessary with decimals. So I don't even need to write it. So I just end up with 23 and 65 hundredths. Finally, I'm rounding to the nearest tenth. Don't worry about the negative. It's not there to trick us. We're rounding to that space so the 7 and the negative both stay the same. All we're asking is, do we stay with a 3 or do we round up to a 4? And that 2 says stay with the 3, stays the same. So I end up with -7 and 3 tenths. All right, so we're going to get into some operations with decimals after the break. And we're back. 5.2, operations with decimals. The reason I wanted to include this here is because there's an extra rule in subtracting. There's an extra rule in division. There's just a couple operations that have a little extra that needs to go with them. Oh, multiplication. Pretty much everything but adding has an extra rule. So I wanted to take some time and talk about those topics. So for subtracting, if I wanted to write this out, and remember what I always say, you never know what day you're going to lose your calculator on. In fact, just today I was doing a problem and I forgot to recharge my calculator and my calculator died. So I had to do stuff by hand. So it happens to the best of us. It's always good to know how to do this stuff by hand. So I'm going to subtract these two numbers. I have 78 as a whole number, and I'm subtracting 6 and 15 hundredths. My decimal is not very clear, so I'm going to rewrite that. I have never come across a Math 80 class that didn't know to line up the decimals. People know to line up the decimals. You come to me already knowing that. But what people forget is that after the decimal is a 0. So I cannot do this subtraction and just bring down the 15 and just subtract and have a merry little time. I cannot do that. What I have to do is I have to fill in the zeros. And anyone out there that's a cashier or works with money and does that daily as part of their job, you know exactly what I'm talking about. We have to have that $78 to subtract that 15 cents from, which means we're going to have to borrow. So I'm going to borrow, and I'm going to do my little trick that I like to do. So I have 80 that I'm borrowing from. I'm going to make that 79 because I'm borrowing one and I'm giving that one here. Now, I'm not going to go into what everything means because technically I borrowed a tenth and I gave it to 10 tenths to the hundredth, and it just gets too much of a mouthful with all those THs in there. My point is, it's the same concept as any borrowing we've ever done. So we can just borrow one and give it to the next one. The only time borrowing gets weird is when fractions are involved, and that's because fractions are not nice like decimals. Fractions do not have tens in them like decimals do. In fact, that prefix right there, DEC, it means 10. So everything is in tens, and we can borrow a 10 and give it to the next guy. Okay, enough said. I'm going to subtract now. 10 minus 5, 9 minus 1, 7 minus 6, and then bring down that 7. Oh, that is not 7 minus 6. There we go. Let me fill in a 1 right there. Okay, so the only other thing I have to do, since I lined up those decimals so nicely, is I just put the decimal straight down. And that's it. So let's try this again. It says add and subtract decimals because on the homework you'll be adding, but I didn't feel like we needed an adding example because you know how to carry. It's really that filling in those zeros on top that gets people. Did I just say we're not doing adding, and here we're doing adding? Goodness me, I should read ahead before I talk. Okay, so Jonah spends $6.35. Oh, did you hear that? Did you hear how we just say and without even knowing it? $6.35 on a hamburger and $2.40 on fries. How much did he spend on his meal? We're taking this as simplest version possible. I'm not worrying about tax. I am not worrying about some sort of DoorDash delivery fee. I am not worrying about tip. I am just adding the two decimals together. And so I line up the decimals like we talked about, and look at this. There's not even any carrying needed. Oops, I don't know what that extra little mark is doing in there. But other than that, we just add like normal. Since this is money, we throw a $sign in our final answer. All right, adding, subtracting, done. Let's look at multiplying and then dividing. So for multiplying, now I'm going to just save this negative. I'm going to put my answer right here. I'm nowhere near ready for the answer, but I'm going to bring that negative down now before I forget about it. Multiplying, it does not matter about lining up the decimals. Just like before, what matters is that you're lining things up on the right side. So I'm going to multiply this like I would before, and I'm not even going to worry about the decimal till the very end. So I do 3 times 6, carry the 1. 3 times 5 is 15, and 1 more is 16. And now I'm looking at that 1 in the tens place. Oh, well, technically it's a 1, but I'm ignoring the decimals right now. So I put a space holder, 1 times 6, 1 times 5, and I add those together. Finally, I need to worry about those decimals. So I'm going to count how many place values were involved, how many numbers after the decimal were involved in this problem. And I do that by counting 1 space, 2 spaces. And so altogether, I'm going to move the decimal over 1, 2 spaces, and I get 7.28. Oh, that was terrible reading. 7 and 28 hundredths as my answer. Another way you can do it, instead of counting decimals, we can just estimate. So I'm just going to make a guess at the answer. So let me try this again. 5.6, 1.3. Well, this is about 6, and this is about 1. So if I multiply the together, the answer should be about 1. About 6. So that tells me this answer of 7 and 28 hundredths, that's a pretty good answer. If I had put the decimal after the 2, or I didn't put the decimal anywhere near anything, then these would all be bad answers because 72 and 8/10 is nowhere near 6. 728 is nowhere near 6. So this place where I put the decimal 7 and 28 hundredths is the best place. So that's if you just want to estimate and you don't want to count the decimals. Either way, you'll get the right answer. Finally, last operation, divide. Ooh, look at this. We have a couple of dividing problems coming up. So first, dividing by a whole number. I didn't leave much space because this doesn't need a lot of space. So I'm dividing by 4, so the 4 goes on the outside. And the inside number is 56 hundredths. And the trick here is you just move the decimal straight up, and you need to be careful that you line up all your numbers after this. And it's not going to be too difficult in this problem to keep your numbers lined up. It might be more difficult in the future if there's zeros involved, which we'll see if that happens. But here, 4 goes into 5 one time, so I'm writing that 1 right on top of the 5 right next to the decimal, so I'm not having to worry about if I'm sloppy or not. And then I multiply, subtract, bring down, and 4 goes into 16 4 times. There's so many different examples of division and multiplication, and so if you come across one in the homework that's maybe harder than one that we've done in class, you can either email me right from the problem. I believe you can just hit a button and it sends me the problem. Or you could also go to that openstacks.org website and check out some examples there. Okay, so this next one, we have a case containing 12 bottles of Gatorade, costs $22.45. How much does each bottle cost to the nearest cent? So this to the nearest cent means, if necessary, we're going to round our answer. So I have 12 bottles, and I'm dividing them into the cost. And if you're not sure what goes where, the in and out little jingle does not work here because there's no fraction involved. So first off, I would just estimate. If I have 12 bottles of Gatorade and it costs, I'm going to just make up a number that's close to 22. I'm going to say 12 bottles of Gatorade cost $24 just to keep the numbers easy. How much money would each bottle cost? Well, it would cost $2. So I know that my answer is going to be somewhere around $2. It's not exactly because this number is not 24, but it's a good estimate. So if I do this division backwards accidentally, first of all, that just looks big and scary and ugly. But as I'm doing this, 22 goes into 12. Not that it doesn't go in at all. And then I would have to do some decimal stuff here. So it's always good to just estimate when you're dividing decimals, because that will get you in the ballpark of the answer that you're looking for. Okay, but that's not the case here. Well, I mean, that was the case, but we have it all set up, right? So 12 goes into 22 one time. 1 times 12 is 12. Subtract, bring down. And now I want to know how many times 12 goes into 104. So I just think about my 12 times tables. And 12 times 8 is going to be 96. So I can use that. And in all of that thinking about 12 times tables, I got a little sloppy and I forgot to put my decimal, so I'm going to do that right now before I forget. Bring it straight up, so it's 1.8. And I'm not even done yet, but I can see 1.8, that's close to $2. $1.80 is close to $2. So I'm definitely on the right track. I don't have the specific answer yet, but I'm definitely getting there. Okay, so I now need to subtract, which is 8 and 5. And then we are now in the situation where 12 does not go into 85 evenly. And this is good. This is one of those weird situations with division that I wanted to talk about. But it does go into 85 7 times, because 12 times 7 is 84. And what we need to do, it says to round to the nearest cent. So what I need to do is continue this problem just long enough to know what that next number is, to know if I need to round that 7 up or if the 7's going to stay the same. So I'm subtracting, and I've run out of things to bring down. So what we do with decimals, if you run out of things to bring down, you just keep adding on zeros, because it doesn't matter how many zeros you add to the end of a decimal, the number will stay the same. So now I can bring down that 0 and say 12 goes into 10 0 times, and I could keep going, but I really don't need to, because this answer needs to be rounded to the nearest cent. I'm cutting off the answer right here anyways. So now that I know there's a 0 after the decimal, I know that I'm not rounding up. I'm going to stay the same at $1.87. And you might say, why did we even do that extra step if we weren't even rounding? Well, how did we know we weren't rounding until we got that 0 is my answer. So we have to keep going until we see what that number tells us to do. Okay, last scenario. I hate dividing decimals as much as you hate watching me divide decimals, but we have to do all the scenarios. So now the final one is dividing a decimal by another decimal. So following the way I set up 4, I'm going to put the 2/10 on the outside and the 24 and 36/100 on the inside. And I will just put my answer right here. And I'm doing this to remember that that negative goes here, because the negative has no business in a long division problem. More stuff just makes it more cluttered. So I'm just going to put that straight in the answer. And so what we need to do when we're dividing by another decimal, so there's 2 decimals involved, or at least the second number is a decimal, we can't have a decimal on the outside. So what we do is we move that decimal place over one place. And if I do it on the outside, I have to also do it on the inside. And so normally I would just keep going. However, it looks pretty sloppy. And if you haven't seen this for a long time, or maybe have never seen this, it's kind of messy. So I'm just going to rewrite it. There's a 2 on the outside. And now there's a 243 and 6/10. This will have the same answer because we moved both numbers over one decimal place. We did it to the same, so it works out. And it's a 2 on the outside. I love 2s on the outside so much better than the 12 on the outside because 2's times tables are way easier than 12's times tables. So 2 goes into 2 one time, nothing, bring down the 4. 2 goes into 4 2 times, nothing, bring down the 3. 2 goes into 3 one time. There is something from that subtraction, but that's okay. I'm not done yet. Bring up that decimal. 2 goes into 16 8 times, and there's nothing left. So the answer is negative 121 and 8/10. There's nothing in the problem that told me it was going to be, the answer is going to be to the 10th place. I just worked out the problem until I ran out of numbers. All right, so in the interest of making these videos shorter, I should have paid attention to when I started it, but I decided I was going to make 2, no technical difficulties. I just want to do the first 2 sections. I'm going to end it here. Gives you a chance, if you haven't paused it at all, it gives you a chance to get caught up on your homework up to this point, and I will come back with the last 2 sections. All right, thank you.